Okay, so at this point we have a high-level state machine. We have the data path associated with supporting that high-level state machine. And from there, what we want to do is come up with the finite state machine that we can use to implement a circuit to control the data path. Okay, so we have the init condition, all right, with a reset the scalar. Okay, and we're going to, in that initial condition, have S equal M. So I look at my data path and I highlight here the multiplexer. So here's the multiplexer coming in here. And I'm asking myself, how do I get M routed to the D register that stores S? All right, and so I'm looking at that. M is connected to line 0. And so what I need to do is select S1 equals 0 and S0 equals 0. That would now select the correct input on the multiplexer and route that to the D register. Okay, so from there, I would go to state P no matter what. In looking at the P state, I don't see any loading of the S register. Okay, I don't need to change the S register in that state. So I can just leave that alone. I think we're done with state C. All right, so from there, we're looking at incrementing. And remember, the logic on this is car out ended with car in bar. And over here, it's car in ended with car out bar. Okay, that's kind of messy, but you get the idea. All right, so in these two states, and then I come back with a 1, both conditions. In these two states, I'm trying to do two different things. On the D state, I want to decrement the S register. So I trace the line for decrement, and I see that's connected to line 1 on the multiplexer. So what do I need to do to select line 1? I need to take output signals, S1 equals 0 and S0 equal 1. 0, 1 is binary 1, and that would select line 1 from the multiplexer, all right, which affects the decrementing of the S register. Okay, similarly for the increment stage, if I take a look, I'm looking at increment connecting to line 2. So I would need S1 equal 1 and S0 equals 0. The other thing that I need to do is when I'm loading the register, I forgot this, I need load S to be 1 because that's the way this data path is set up. I need to load the register to make it do something. This essentially enables it so that it can load. Okay, of course it loads on a clock signal. And the value that's loaded is on the D input. And I think you know all that. Okay, so the same thing down here. I need load S to be 1 every time I'm loading that S register. Okay, so here we go. That's the finite state machine associated with this problem. Next thing we're going to do is we're going to turn this into a one's hot circuit. So that'll be the next video.